All right, Math 2 students, here we go with a quick review of the number of roots that each expression will have. So if we start at the top right here with a radicand of 0, it does not matter what the index number is. It can be any number because the root of any radical problem that has a radicand of 0 has to be 0. It doesn't matter how many zeros we need to multiply together to get 0, it will be 0. So on this problem, we know that the answer is the root equals 0. So there's one root, and that root is 0. That is true of every problem where the radicand is 0. On the next problem, we have the cube root, or an index number of 3, of negative 64. Well, I know that 4 times 4 times 4 is 64, and that's 3 4s. So if I want to get negative 64 with that odd index number, then I'm going to use 3 negative 4s. So I have negative 4 times negative 4, which is positive 16, times negative 4, which would be negative 64. So as you can see, when we have an odd index number and a negative radicand, we're going to have one real number root, and our real number root on this problem is negative 4. All right, on the next problem, we're taking the fourth root of 81. And I know that 3 times 3 is 9, times 3 is 27, times 3 is 81. So it looks like on this problem, our root is 3. The only problem is we have an even index number. So we're up here at the top with an even index number, and we have a positive radicand. So we should end up with 2 real number solutions. So that reminds me that with an even index number, we could have negative 3 times negative 3 times negative 3 times negative 3. And these two pair up to make positive 9. And these two pair up to make positive 9. And 9 times 9 is positive 81. So our root is also negative 3. And finally, we have the square root of negative 25. Remember, a square root has an index number of 2. And so 25 is easy. I know that it's 5 times 5. But 5 times 5 is not negative 25. It's positive 25. And so then I could try negative 5. And negative 5 times negative 5 is also positive 25. So this problem has no real number root. Now we're going to take a look at changing the structure from a problem that has a radical sign to a problem that has an exponent that's a fraction. So on the left side of the screen, we have the cubed root, which means you have an index number of 3, the cube root of 10, and that is to the 5th power. If we want to rewrite that with an exponent that's a fraction, then the problem is going to have a radicand of 10, which means it has a base of 10. And then the exponent will be a fraction. And as you can see here on the pink oval, whatever the index number is, that number ends up being the denominator of the fraction. And whatever the exponent is, that ends up being the numerator of the fraction. So our index number is 3. That will be the denominator. And our exponent is 5. That will be the numerator. So these two expressions that I'm putting in the orange box have the exact same value. The top one is in radical form. The bottom one has an exponent, so it's in exponent form, but it's called a rational exponent because the exponent is a fraction. On the right-hand side of the screen, we're just going to do the same thing, but in reverse. Here's our radical sign. and we have our rational exponent up there. Our base is 13, so our radicand is going to be 13. Our denominator is 4, so our index number is going to be 4. And we don't have an exponent that will be a shown exponent. So since the exponent is a 1, we could write it like that, but normally in math, you don't write unwritten ones. So the problem would just look like this. And now both of these expressions that are in the orange box are exactly the same thing. All right, so now we're going to learn how to use the Casio FX 300 ES Plus to do the problem, the cube root of 512 to the second power. Notice it's called the cube root whenever the index number is a 3. So the first thing I need to do is I need to use the right parenthesis. And then once I have the right parenthesis in there, I have to use the radical symbol. And there's a few of them on the calculator. There's one here, there's one here, there's one here. And although we could use this one, which is to the third power, I'm going to go ahead and use the one that works for every problem when you have an index number that might be different than 2 or 3. So that is a gold colored button. So I need to go to Shift, which is in gold. And then when I hit that button, the gold function will come up on the calculator. So you can see now there's a box for the index number and a box for the radicand. I'm going to hit 3 because the index number is blinking. Then I'm going to have to hit the right arrow, and that's going to get me down to where I can put in the radicand, which is 512. Now, this is important. You got to get yourself out from under the radical symbol. Otherwise, you'll continue to type under the radical symbol when in this problem we don't want to. So I hit the right arrow. That takes me out from underneath the radical symbol. I hit the right parentheses. Now the only thing I'm missing is the exponent to the second power. So I hit the exponent button and I put a 2 in the box. And so now if you look at the original problem that's written on paper and the problem that's on the calculator screen, they're identical. So I hit equals or enter, and the answer comes out to 64. All right, so now I'm going to change it up, and I'm going to do this problem that has a rational exponent or an exponent that's a fraction. So on this problem, I'm going to do all clear, and then my base is 5, and then I need to hit the exponent button. So I hit the exponent button right here, and now it has an exponent, but the exponent is not a fraction. So I'm going to go to the fraction button right here, and I'm going to put a fraction inside the exponent button. So now my denominator is, or my numerator is 4, and my denominator, notice I had to hit the down arrow, is 5. So now the problem on the piece of paper looks exactly like the problem that's on the screen. When I hit enter or equals, it comes out to 3.623898318. All right, so if you are not using the Casio FX 300 ES Plus, you should use the Desmos scientific calculator. So just open a new browser tab, type in Desmos, DESMOS.com, and that'll take you to the Desmos website. And you want to hit Math Tools and pick Scientific Calculator. And then this calculator, we'll be able to do these kind of problems without any worries. So we're going to start with the top one. Here's where you find the left parentheses button. Then I need to use the radical symbol that allows me to put in different index numbers. That's this radical symbol right here. So now you can see it's blinking, so the cursor is ready for the index number, which is a 3. Now I'm going to go click, and I'm going to put in my radicand, which is 10. Now, this is a big problem. If I keep typing, everything I type will be underneath the radical symbol. I don't want that. So what I need to do is hit the right arrow, which will get me out from under the radical symbol. Then I'm going to hit the right parentheses. And then this is the exponent button. And I'm going to add an exponent of 5. And so now what is written right here is exactly the same as what is written right here. And it tells me that the answer is 46.415888834. And if I hit the enter key, it'll just keep track of it up here for me, and I can start the next problem. The next problem is 13 to the 1/4 power. So I'm just going to type in 13, then I need to hit the exponent button. And so now the cursor is ready for the exponent, but my exponent is a fraction. So I have to come over here to the A/B exponent button, and I hit that. And now the cursor is ready for the numerator. So my numerator is 1, and my denominator is 4. And so I have 13 to the 1/4 power. It looks just like this right here. And my answer is 1.8988288922. And if I hit enter, I'm ready for the next problem. And I've kept track of the problems that I've already done, which is pretty cool.